Next, we will continue talking in this part of the course about temperature sensors. We will be seeing many details about the sensors, their resistance values. We will be understanding how they work in a conventional and inverter system. We will also be understanding how an electronic board can make these be part of the electronic circuit. That is, part of the electronic board influences the operation of temperature sensors. Something that can be damaged in this system is not only the sensors, but also the circuit involved in temperature measurement inside the electronic board. So we will explain all that, but to start we will be seeing or understanding how these temperature sensors work. It is key to understand how they work, and that is what I will apply. These temperature sensors are NTC. That is, their temperature coefficient is negative. What does it mean? That it is exactly the opposite of its operation in resistance. To understand it better, we will make a small graph in which the variable below is the temperature in degrees Celsius, and the vertical variable is the resistance in ohms. As the temperature increases, the resistance decreases. These temperature sensors are small NTC ceramics because their reaction to temperature is to reduce resistance. It has been reached as a kind of agreement between manufacturers, and it has been said that to name a sensor, we will say what value of resistance it maintains at 25 degrees Celsius. To name a certain sensor, we will use as a reference its resistance value at 25 degrees Celsius. So you are finding, for example, 10 kilo ohm sensors on the market. What does it mean? That at 25 degrees, that sensor has a resistance of 10 kilo ohms. What do we mean by resistance? I will do a small measurement to understand and know what it is about. For those who have never done it, we grab the multimeter, put it in resistance position, and simply measure the sensor uninstalled from the electronic board. Well, here we have a 10K sensor. Why do 8K appear at this point? Because evidently we have a temperature greater than 25 degrees here. As its coefficient with the temperature is negative, this sensor evidently, as all sensors, has a graph that looks like this, and we will have 8 kilo ohms when the temperature is a little higher. In this place, it should be about 28 degrees Celsius now, so we have 8K of resistance. Remember the word NTC. This will help us understand that if we increase the temperature, the resistance decreases. It is negative, it is the opposite. Now, PTCs are different. This is only for informational purposes. It is not relevant in the case of inverters. PTCs are ceramics that are used, for example, to start refrigerator motors whose coefficient with the temperature is positive. What does this mean? As the temperature increases, the resistance increases. A PTC, for example those that are used to start refrigerators at 25 degrees, is approximately at 20 ohms. There it is, more or less you can see it. So, when the temperature increases, the resistance increases. The difference between PTCs and NTCs is that they are positive in relation to temperature, that is, they increase and continue to increase. PTCs are often used as starting devices because their line is not predictable. That is, if it heats up faster, the line will be like this. If it heats up slower, the line will be like this. And when it cools down, it will be different. The same ceramic can find in different temperatures several resistance ranges because its working line is not predictable. So it is used as a starting device. The temperature increases, the resistance increases, and the starting coil detaches, as is the case with refrigerators. NTCs are predictable, which is why they are used for precision temperature measurement, and that is why NTCs are the ones we will always find in areas where temperatures need to be measured. Okay, this is how NTC ceramic sensors work. What values do each ceramic have? We can't see it from the outside because it's actually a package. The ceramic is inside. The ceramic looks similar to the one I'm going to show in an image, so you know what it looks like inside, and also see why you won't have the value on this component because this is not the sensor. The sensor is inside. Something like this is what these small ceramics look like. An important detail to keep in mind, there are many values. If a manufacturer tells us that this sensor is 10K, here he is indicating that it is 10K at 25 degrees. But you will also find them, as many already know, you will also be finding them, for example, always talking about 25 degrees. The value I say in kilo ohms or less is the reference temperature value at 25 degrees. So far you have found 5K in conventional equipment, 10K, 15K, and 20K. And in refrigerators, for example, the Whirlpool brand has a 2.7K sensor, others also use 5K. Well, what does it mean when a manufacturer or a spare parts seller tells us that this sensor is 15K? Remember that he is telling us that it maintains this value at 25 degrees. It is not that it is always 10K. In fact, we just saw it with this sensor. Right now it has 8 kilo ohms of resistance because we have more than 25 degrees. It reacted to the temperature, which is fine, it is correct. Something else that we also need to understand is that we need different values of sensors depending on where we are going to place them. Let me tell you the following. When we talk about 10K, the letter K represents a multiplication by 1000, so in reality this sensor is 10,000 ohms. Temperature sensors on electronic boards have high resistance values. They are not 10, 100 ohms. No, we are talking about 2,700 ohms, 5,000 or 10,000, 15,000, 20,000. Okay, this is how temperature sensors work. I will explain below their application in air conditioning systems and also in inverter systems. Please leave a comment if you have any questions.